Hey you guys, so we're just going to talk about those rules of probability that we've talked about so far, such as the probability of not an event we know is 1 minus the probability of that event happening. The other example was the probability of A or B. If they are mutually exclusive, we use the probability of A plus the probability of B. And if it's not mutually exclusive, then remember that we can't just add them together because there's something in common, so we subtract what they have in common. So that is A and B. So again, A and B is what is in common. All right, so let's just do some examples of each of this. So we said probability notation is P of E, where E in this case is an event. So let's do some basic examples. What's the probability that the spinner will stop on green? Well, we know that the probability we have is the frequency of that event divided by the total. So I see that there's one green out of that spinner, and that's out of 1, 2, 3, 4, 5, 6, 7, 8 colors, so that would be 1 out of 8. What is the probability that the spinner will stop on red? Well, we actually have 2 that are red, so the probability of red would be 2 out of 8, or if we reduce that down to 1/4. Like I said, our addition rule, if it's mutually exclusive, we just add those up. So or means to add. What is the probability that the spinner will stop on green or red? So we said that green was 1 out of 8, and remember that red was 2 out of 8. Notice that it's either green or it's red, right? It's not going to be an overlap. So these are mutually exclusive. So or means to add. We're going to take 1/8 and add 2/8, and we get 3/8. Great. What is the probability that the spinner will stop on orange, pink, or gray? So notice that we can have lots of ors. So again, 1 out of the 8 is orange, 1 out of the 8 is pink, and 1 out of the 8 is gray. So 1 plus 1 plus 1 is 3/8. Again, our complement rule is 1 minus the probability of not the event. Let's go back to our spinner. What's the probability it will not stop on green? So probability of not on green, there's 2 ways we could do this, right? We could just say, there's 1, there's 8 of them, and also that would be 9/8. Or we could use our probability rule, which says there's 1/8 that's green, so 1 minus 1/8 would give us 9/8. What about not orange, pink, or gray? So it's not orange, not orange, or not pink, or not gray. So again, 1 minus the probability that it is orange, or pink, or gray. And we said just a moment ago that that's 3/8 for it to be orange or pink or gray. So 1 minus 3/8 would be 5/8. Now, most of the time we're going to use our general addition rule, because even if they are mutually exclusive, they don't have anything in common, so this probability would be just 0. But this is a great rule to know. So probability of A plus B minus what they have in common. On New Year's Eve, the probability of a person having a car accident is 0.09. So car accident is 0.09. I'm going to write that down. So having an accident is 0.09. The probability of a person driving while intoxicated is 0.32. I'm going to write that down. What does that mean? That's intoxicated is 0.32. The probability of a person having a car accident while intoxicated is 0.15. So that means they had the accident and they were intoxicated. So that means that they have in common 0.15. We want to know the probability of a person driving while intoxicated or having a car accident. So intoxicated or the accident. This is our rule, right? So think of, these are the people who had the accident. Here's a group of people that were intoxicated, and the group right in the middle. So we can't count that group twice. So we're going to add the intoxicated and the accidents, but we're going to subtract the accident and the intoxicated. And when we do that, 0.32 plus 0.09 minus 0.15, we get 0.26. One more, just for fun. According to the current population reports published by the Census Bureau, 51.8% of U.S. adults are female. 10.2% are divorced and 6% are divorced females. F is the event the person is female. D is the event the person is divorced. So we want to know the probability of being female. So we read and look, there's 51.8% of U.S. adults are female. As a probability, that is 0.518. So we've got to change it to a probability. This is the percent. We want the probability. All right, divorced. So we come up here. 2.2% are divorced. So that is 0.102. Remember, percent means we're per 100, so we just divide by 100. Female and divorced. And look here, 6% are divorced females. That means they are divorced and they're females. So that would be 0.06. Now we want female or divorced. That means we're going to take the females. We're going to add our divorced people to it. And we are going to subtract what they have in common. So that is 0.518 plus 0.102. And we're going to subtract 0.06. And we get 0.56. So there's 56% of people that are female or divorced. So think of that as, here's female people, here's divorced people. We know that, we have some that are both female and divorced, and we want all of it, right? So these are, over here, the males that are divorced. Speaking of males, what is the probability of being a male? Well, for statistics, if you are female, then you are not male. So we are finding the probability of not being female. As far as this text knows, that's all it is. So we're going to use our rule, our complement rule. So we know that females up here, we said was 0.518. So the probability of being male then is 0.482. All right, I hope this helps. Get all those rules kind of down pat in your head. I'll see you next time for the next installment of Probability and Statistics.